Hi, welcome to chapter 11 of operating systems. Right? So today we're going to talk about mass storage systems. Right? And when we look into the mass storage area, right, chapters, there are a couple of things first that we're going to go through, particularly on overview of the mass storage itself. We're talking about hard disk and etc. And then how hard disk accessing the hard disk itself has a scheduling algorithm, so we're going to talk about those scheduling algorithms. We're going to talk about non-volatile memories. We're going to probably depending on how we deal with this semester, I don't think we'll be covering on the non-volatile memory scheduling. uh, and we're going to skip error detection and correction, but we're definitely going to cover storage device management, swap space management, storage attachment, and RAID structures basically. Okay, so look at this. Bulk of secondary storage for most operating systems are hard disk and non-volatile memory. So when we talk about non-volatile memory, like this memory that we can actually be persistent, right, when we save them, right? So for example, solid state hard disk are basically non-volatile, right? In the case of a hard disk, it's basically a disk that spins, right? That's why we call it a hard disk. It's The disk is basically coated in magnetic material, right, that we can magnetize to indicate zeros and ones, and therefore capable of keeping information, right? Now the disk itself rotates about 60 to 250 times per second, so they actually spins pretty fast, right? And within that, the performance of the disk is basically measured by the transfer rate, how fast it can transfer data, and positioning timing, right? So how fast is it to look for information in the hard disk. And when you're looking for this, basically the positioning issue basically has two types of problem. One is how long does it take for us to basically move to a position on the disk where the data is, we call the seek time, or how fast does the disk needs to spin in order to get to the correct position of the data, right? And also there's a terminology there where head crash, right? Where the disk becomes bad because damage when as the disk spins, it hits the head, and it causes the disk to scratch, and therefore cannot keep information very well, right? So basically when we talk about this is basically a hard disk. It rotates within the spindle, right? And each disk basically has a track, right? So so each disk is like a horse track on the disk. So there are multiple disks layered together, right? And each disk would have multiple tracks, and each track would have multiple sectors where we can keep information, right? And what it has is basically an arm here, and that arm kind of move to make sure whether it sits at track 1 here or at the end of the track of the edge of the speed disk, pretty much, right? So that's basically how it works, right? So platters are for so a bunch of these are called platters, and platters are basically can be about 0.85 to 14 uh, 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 thick uh, thickness wise, inch thickness wise, right? So the range you can keep for anything 30 gigabyte to 3 terabytes per drive, right? Performance basically in theory can reach 6 gigabyte per second. It depends usually. right? And transfer rate, seek time, basically are some of the performance measurement on a hard disk, basically. Right? So you can basically calculate the performance of the disk. So for example, if you want to access the latency right here, or the average access time here, right? The way to calculate is by calculating the average seek time plus the average latency, right? So for fast disk we can have about 5 millisecond, for slower disk about 14.56 millisecond of average seek time, right? So they also average IO time. This is the average access time plus the amount transfer rate plus the controller overhead time, right? So these are some of the performance issues in it, right? So for example, if you are given a disk with a to transfer a 4 kilobyte block on a disk that spins at 72,000 rpm with a 5 millisecond average seek time, then you are able to calculate the delay here, right? So you can basically calculate 5 millisecond, which is the average access time, right? Average seek time, right? So access time equals to average seek time plus the average latency, right? So plus the 4.17 millisecond, right? And 0.1 controller delay, right? So you can calculate 72 rpm, right? Plus the transfer time, right? So the transfer time for 4 kilobyte divide by 1 gigabyte per second, you can calculate that and it will give you 0.031, right? The average IO time for kilobyte is can also be calculated as 9.2 millisecond plus 0.31 right here, right? And you will get basically the 9.301 millisecond for the average time for 4 kilobyte to be transferred, right? All right, so that is basically how you calculate those, right? Right. So if we're looking at so take a look, average IO time here is average IO time here. So if you're trying to calculate the average IO time, you still have to add the 9.27 this amount, right? Plus the transfer time 0.31, right? So this would be the average IO time, right, for this one, right? So follow this and you get some of the calculations correct, right? The first commercial disk was basically created in 1956, right? It's basically this size over here, right? Just the hard disk, pretty big, right? It's basically a drum, right? Now for non-volatile disk, we have something like the solid state. They are much faster, and USB drives are solid state. If you look into your solid state hard disk, this is basically how it looks like. They are basically memory blocks where you can read and write stuff, right? Now solid state are nice, but it does have a lifespan, right? So the solid state itself can only be erased a limited number of times before it get worn out. Roughly that figure is about 100,000 times. So after a while your solid state hard disk doesn't work anymore, right? And that's basically it, right? So the lifespan is measured in drive writes per day, right? DWPD, right? And usually when you buy solid state hard disk or USB thumb drives, these are basically stated as well, right? What the DWPD is for that particular device. Now, if you're using a some of these non-volatile memories, you may require a controller, right? And they have some kind of controller algorithm to make sure that you won't be writing at the same place too many times, because this actually makes it um, you know uh, broken, or you use up your 100,000 writes faster, right? So there is an algorithm to randomize that, so that some of the block pages being accessed doesn't access the same thing, right? Besides volatile memory, non-volatile memory, you also have volatile memory. Volatile memories are like RAM, right? uh, when you turn it off, it disappears. So that's basically about non-volatile memories, right? In the olden days, we do have magnetic tapes. We don't, to save very large information. Today, we don't use that much anymore, right? Okay, so I'm gonna skip some of these parts, right? Okay, and we'll continue back in in a bit, right? After this, let's take a short break for a while.